All right, this is video 1.5. Today we're talking about some of the formulas that you'll be using in geometry. Go ahead and write these down in a place where you can memorize them. You use them a lot. It's something that you need to put the effort into knowing what they are and being able to use them very quickly. So the first one is perimeter. Hopefully it's not a brand new word to you. Basically the perimeter is going to be the sum of the sides of the figure. So if you had a pasture that looked like this, your perimeter, how much fencing you would need, would be to add all your sides up, and that would be your perimeter. So that's something that's pretty important for anybody who has a yard. But also anybody who wants to paint the inside of their house. Your perimeter has to do with how many walls you have, and how much paint you would need to get is going to be the area of your walls, and that's actually going to be surface area. We'll get into that later. So for a rectangle, the formula, the easiest way to use it is going to be 2 of your lengths plus 2 of your width. So if you've got an L and a W and an L and a W, you could say L plus W plus W, but L plus L is really 2L, and 2 W's is really 2 W's, like that. So this is going to be the formula for the perimeter. In a square, square by definition means that all the sides are the same. So that's not a good square. One second. So if we have a square, we could say that each of the sides are the same. So we could say we have our 4 sides, which would be S plus S plus S plus S, or 4S. So that's going to be the formula that we would use for a square. In a triangle, what's going to be important is that if you've got A, B, and C as your sides, this is mainly for area, but your B is always going to be your base, right? So for a triangle, it's just going to be you've got this side plus that side plus your C side. And you can't really reduce that any at all, so our formula would just be A plus B plus C, keeping in mind that B has to be the base. For area, area is going to be, it's how many non-overlapping square units of a given size cover a figure. So if we have a rectangle and we were to use square units to figure exactly how much covers that, then that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The area of this figure would be 10. So if you look at it as a rectangle that way, we can see that we have 5 units going lengthwise and 2 units going widthwise, and so 5 times 2 would be 10. So for a rectangle, the way you do it is you're going to do your length, like here, times your width. So here our length was 5 and our width was 2, which gives us 10 units, which is what we counted on the inside. For a square, we're just going to take our sides squared. So remember that for a square, if this is the side and this is the side, then you're doing basically length times width, which would be S times S, and S times S is S squared. So in this case, we've got 4. So it's 2 units this way and 2 units that way, because it's a square, would be 4, which is what we could count if we were counting on the inside of our diagram here. And for a triangle, we'll do 1/2 of the base times the height. So remember, if we've got A, B, and C, we're going to add a height dimension to this, which is going to be from the top of your angle here that is between A and C, drop down to your base. So that would be for this type of triangle. In this case, your height is actually going to be your C, and if you have an obtuse triangle, this over here would be your base, and your height would be right here. And you can tell because you're going from the right angle or the bigger angle down toward the longest side. Your base is going to be your longest side. So let's find some perimeter and areas. Let's say we have a rectangle that has a length of 17 and a width of 5. So let's find our perimeter first. Remember, our perimeter is going to be 2L plus 2W. So 2 L's would be 2 times 17, plus 2 W's would be 2 times 5. My 2 times 17 is going to be a 34, plus 10, giving me a perimeter of 44 centimeters. My area is going to be length times width, so that would be 17 times 5, which gives us 85 centimeters squared, because this is a centimeter and this is a centimeter, so when we multiply them together, our units become square. And if you think back to the boxes that we just did, they were squares what were inside. Okay, so if this is a centimeter and this is a centimeter, we have centimeters squared. So area is always going to be your unit squared. Perimeter, the unit is not squared. So let's do a triangle. We have A is 8, B is x plus 1, C is 4x, so those are our sides. And then our height is 6, right? So remember, our perimeter is going to be A plus B plus C. So that would be 8 plus x plus 1 plus 4x. I have a positive sign in front of my parentheses, so I'm just going to drop my parentheses. The signs don't change. So I have 8 plus x plus 1 plus 4x. 8 plus 1 would be 9. X plus 4x would be 5x. So that is my perimeter. All right, so to find my area, I'm going to do 1/2 of my base times my height. So I'm going to use this as my base. So I'll do 1/2 x plus 1 times 6. So anytime you've got them multiplied, so I'm just going to stick these over once so that we can see that we are multiplying fractions. I have my 2 on the bottom. I can go ahead and divide x plus 1 divided by 2. I could distribute my 6 to my x and to my 1. That would work. Or I can just go ahead and reduce my 1/2 and my 6 here. That 2 is going to turn into a 1 and the 6 would turn into a 3. And now I'm going to distribute my 3 to my 1 and my 3 to my x, giving me 3x plus 3. Let me show you what would happen if you multiply your x plus 1 plus your 6, times your 6, and then divide it in half. So the other way you could look at this is x plus 1 times 6 divided by 2. So if I distribute my 6, I would have 6x plus 6 divided by 2. That would reduce down to a 3, and that one would reduce down to a 3, giving me 3x plus 3. So I come up with the same answer either way. The fastest way for me to do it is I look at my denominator and see if I can cancel it out with any of my numerators that I have, just to get rid of the fraction as quickly as possible. For circles, slightly different. So a circle here, you've got your center of your circle. By definition, a circle means that every point on the outside line is the same distance from your center. The diameter is going to be a segment, if I can draw a straight line, that goes from one side of the circle to the other through the center, all right? And it could be anywhere on the out point of the circle, but it has to go through the center. So if it doesn't go through the center, it's not a diameter. It's generally referred to as a lowercase d. The radius is going to be from your center to any point on the outside of the circle, and we will call that r. Now, the diameter is actually 2 r's. You have this r plus this r, right? So your d is actually equal to 2r, if that helps you remember what the relationship is between them. So the circumference is going to be how far it was around the circle. Say you take a piece of string and you wrap it around your soccer ball or your basketball, and then you straighten your string out. That was the distance around the circle. That is your circumference. So the formula for your circumference is you take the number pi and you multiply it by your d, if that's what you have. If you don't have a d, then you multiply it by twice your radius, because remember, your diameter is twice of the radius. And then area, use the same numbers, is going to be pi r squared. So when you do this, you're not squaring pi, you're only squaring the radius. If you don't have a radius, Then you take and you have a diameter, then you divide your diameter in half to get a radius and then square that. So let's do a couple. We're going to find the circumference and the area of our circle. So remember, our circumference is 2 pi r. I chose that one because what I have is an r. So I'm going to replace my r with a 3, and I will get 2 pi 3. I can multiply my 2 and my 3, giving me 6 pi. And I can leave it just like this. This is called leaving it in terms of pi, 6 pi. The other thing that you can do is you can go ahead and estimate out what 6 pi is, which would be 18.8 centimeters. So you could leave it as 6 pi centimeters or 18.8 centimeters. Either one of those would be considered to be correct. Sometimes I will ask you to leave it in terms of pi. That just means leave your pi in your answer rather than actually multiplying it out on your calculator. So our area is going to be pi r squared. So our r once again is 3, so that would be pi times 3 squared. Remember, the pi is not squared, just the 3, so this would be 9 pi centimeters squared. Or if you multiply it on out, would be 28.3 centimeters squared. Either of those answers would be totally fine. When you do that and you're wanting to get an estimated answer, a single decimal place will be sufficient for the correct answer if you have more than one decimal place that is offered. Now, in general, just as a little pet peeve thing, when you write and leave it in terms of pi, your number goes in the front, pi goes second. Just like you don't usually write x2, you would write 2x. That's what's considered acceptable, and that's not. 9 pi would be considered acceptable, and pi 9, well, it means the same thing, is generally not the order that you write things down in. So when you come to class tomorrow, be able to find the area and perimeter of each kind of figure, and that would be rectangles and squares and triangles and circles. So I hope you have a great evening.